Hello everyone, welcome back to my channel GVS Chem. In this module, let us discuss heat capacity at constant volume and heat capacity at a constant pressure. Relation between them. We also do some numericals in this module. Please subscribe to my channel, like, share and comment on my videos. Extensive properties are those which depend upon bulk of the substance or quantity of the substance. So, extensive properties depend on bulk or quantity of the substance. Quantity of the substance. Quantity means amount. Amount of the substance. More the amount of substance, more is the characteristic. For example, mass, volume, heat capacity, enthalpy, entropy, etc. So, bulk or quantity of the substance and such properties are called extensive properties. So, examples of extensive properties: mass, volume, heat capacity, enthalpy, entropy, etc. Now, let us see the intensive properties. Intensive properties are just opposite to this. Extensive properties depend on the bulk of the substance, whereas intensive properties do not depend on the bulk of the substance, or quantity of the substance. So, what are the examples for this? Density, temperature, refractive index, heat, molar heat capacity, To understand this, assume a vessel with volume V and temperature T. So, a vessel, this vessel has volume V and temperature T. Now, imagine to divide this vessel into two halves by making a partition. So, divide this into two parts. So, as shown here. So, volume of each part is V by 2. Volume of each part equal to V by 2. Therefore, volume decreases. Thus, volume is extensive property. Whereas, even if the vessel is divided into two parts, the temperature of both the parts is same. That is, T is same. Therefore, T is same. T is same means it does not depend on the quantity of the substance. Therefore, T is a intensive property, whereas volume is extensive property. The quantity of heat absorbed or released, quantity of heat or amount of heat absorbed or released is directly proportional to the rise in temperature. If the rise in temperature is more, it takes more heat. If rise in temperature is less, that is, it takes less heat. That means if it takes less heat, the rise in temperature is less, whereas the substance takes more heat, the rise in temperature is more. The quantity of heat is denoted by Q. Q is directly proportional to rise or loss of temperature means, that is, change in temperature. Change in temperature is denoted by delta T, or Q is equal to C into delta T, where C is Q equal to C into delta T. C is a constant, and this constant is known as heat capacity, constant called heat capacity. How do we define the heat capacity? See here, heat capacity C equal to Q by delta T, right? So if delta T is equal to 1 degree centigrade rise or loss or 1 K, that is Kelvin, then what happens? The heat absorbed is equal to heat capacity. Therefore, the quantity of heat supplied for rising 1 degree centigrade of the substance is known as heat capacity. So heat capacity means it is the amount of heat required to rise the temperature of a substance by 1 degree centigrade or 1 degree Kelvin is known as heat capacity. Thus C equal to Q by delta T. Now let us see units of heat capacity. Units of heat capacity. What is the unit of heat? Joule. Joule. Change in temperature, degree centigrade, or degree centigrade minus 1, or joule K minus 1. So unit of heat capacity is joule per degree centigrade or joule per Kelvin. Now let us see the specific heat capacity. Specific heat capacity. Specific heat capacity. In case of heat capacity, we did not mention the amount of substance, that is the quantity of substance, whereas in specific heat capacity we mention the quantity of the substance, that is the amount of heat required to raise the temperature of 1 gram of the substance, 1 gram of the substance, 1 degree centigrade, 1 gram of the substance by 1 degree centigrade. Thus, heat capacity, specific heat capacity is equal to heat capacity by mass of the substance. Heat capacity by mass of the substance. So, specific heat capacity can be represented by small c. Therefore, small c is equal to cap C. Cap C means it is a heat capacity. Heat capacity by m, that is mass. But what is heat capacity? Heat capacity is equal to Q by delta T. This is into 1 by m. So, specific heat capacity equal to Q by delta T into m. Or otherwise, Q is equal to, bring this to this side, C into M into delta T. Therefore, quantity of heat absorbed or released by a substance is equal to specific heat capacity into mass of the substance into difference in temperature. Now, units of specific heat capacity. So here C equal to C by M. What is C specific heat capacity? What is the unit of specific heat capacity? Joule per K minus 1 by, what is the unit of mass? Gram. So this is equal to joule gram inverse and K inverse, or joule gram inverse degree centigrade inverse. So this is the unit of specific heat capacity. Now let us see the molar heat capacity. Molar heat capacity. Molar means 1 mole of the substance. Just now we discussed about the specific heat capacity. Specific heat capacity means it is the amount of heat required to rise the temperature of 1 gram of the substance. If 1 gram is multiplied by molar mass, it is nothing but molar heat capacity. So, molar heat capacity is obtained. Molar heat capacity equal to specific heat capacity into molar mass. Specific heat capacity into molar mass. Therefore, we can write in other way also. Molar heat capacity is equal to heat capacity by number of moles. Heat capacity by number of moles. So this is a molar heat capacity Cm equal to C by N. C by N. What is the specific heat capacity unit? Unit of specific heat capacity is joule per K minus 1. Here number of moles means mole minus 1. So unit of molar heat capacity is joule per K minus 1 mole minus 1 or joule degree centigrade minus 1 mole minus 1. As we discussed, the heat content of the system is measured in two ways, that is internal energy and enthalpy. So heat content is measured in two ways. What are those? Heat content at constant volume. Heat content at constant volume. Heat content at a constant volume is QV. This is nothing but delta U, that is change in internal energy. So internal energy is nothing but heat content at constant volume. Similarly, heat content at constant pressure. So heat content at constant pressure is nothing but QP. QP equal to delta H. QP equal to delta H. So QP equal to delta H. So this is a QP and QV. Similarly, as heat content is measured at two parameters, that is constant volume and constant pressure, specific heat capacity also measured in heat capacity is also measured constant volume measured is CV. CV means heat capacity at constant volume and constant pressure, that is CP. So CP is a heat capacity at constant volume, CP is the constant heat capacity at constant pressure. Now let us see the relation between CV and CP. So relation between CV and CP. So what is a QV? QV equal to delta U. QV equal to delta U. So this QV is nothing but the amount of heat absorbed by the substance at a constant volume, that is CV into delta T. So CV into delta T is the amount of, CV is the heat capacity at constant volume. If CV is multiplied by rise or loss of temperature, then we get the amount of heat absorbed or released. In the same manner, QP means heat content at constant pressure. QV equal to delta H is equal to CP into delta T. So heat capacity at constant pressure into rise in temperature is nothing but QP, which is nothing but delta H. Now for 1 mole of the gas, N equal to 1. Then what is the relation between delta H and delta U? Relation between delta H and delta U is delta H is equal to delta U plus P delta V. So delta H equal to delta U plus P delta V. For ideal gas, PV equal to nRT. PV equal to nRT. For 1 mole of the gas, PV is equal to RT. PV is equal to RT. Right. Delta H means it is at a constant pressure, no? Therefore, P delta V is equal to R into delta T. So in place of P delta V, we can write R into delta V. Therefore, delta H equal to delta U plus R delta T. R delta T. But what is delta H? Delta H is nothing but the quantity of heat at constant pressure, that is Cp into delta T is equal to delta U, that is internal energy, is the heat content at constant volume, that is Cv into delta T. So this is plus R into delta T. So delta T is common factor on both the sides, therefore we can delete this. Delta, this is Cp into delta T is equal to delta T, you take out a common factor, Cv plus R. So this is nothing but Cp equal to Cv plus R. So this is the relation between delta Cp and Cv, that is heat capacity at constant pressure and heat capacity at constant volume, Cp equal to Cv plus R. The value of Cv depends on the degrees of freedom. Degrees of freedom. So for monoatomic gases, degree of freedom F is equal to 3. For diatomic gases, degrees of freedom F equal to 5. For triatomic gases, degrees of freedom F equal to 6. So using this, we can find the value of Cp and Cv. Therefore, Cv equal to, for any gas, F by 2 into R. F by 2 into R. So for monoatomic gases, Cv equal to, F is how much? 3 by 2 into R. Whereas Cp equal to Cv plus R implies, what is Cp? Cv is 3 by 2 R plus R. What is this value? This is nothing but equal to 5 by 2 R. So for diatomic gases, number of degrees of freedom F equal to 5. Therefore, Cv equal to F by 2 into R implies F is 5 by 2 into R. Whereas Cp for diatomic gases is Cv plus R implies 5 by 2 R plus R. This equal to 7 by 2 R. Whereas for triatomic gases, number of degrees of freedom F equal to 6. Therefore, Cv equal to F by 2 into R equal to 6 by 2 into R. This is nothing but 3R. In the same manner, Cp equal to Cv plus R. 3R plus R is equal to 4R. Now let us find the relation between Cp and Cv in terms of numerical values. So here, this is nature of the gas, number of degrees of freedom of the gas, Cp, that is heat capacity at constant volume, heat capacity at constant pressure. This is heat capacity, we can call it as heat capacity or molar heat capacity. And the ratio of both the heat capacity, that is gamma equal to Cp by Cv. So for monoatomic gases, degrees of freedom F equal to 3, Cv equal to F by 2 into R, that is 3 by 2 R. Whereas Cp equal to Cv plus R, 3 by 2 R plus R is equal to 5 by 2 R. Now, gamma equal to Cp by Cv is equal to 5 by 2 R divided by 3 by 2 R. That is nothing but 5 by 3 equal to 1.66. So, if the gamma value we get 1.66, then it is understood as a monoatomic gases. For diatomic gases, the number of degrees of freedom is 5. Cv equal to 5 by 2 R. Cp is equal to Cv plus R, that is nothing but 7 by 2 R. and gamma equal to 7 by 2r divided by 5 by 2r is nothing but 7 by 5 is nothing but 1.4. Whereas for triatomic gases, number of degrees of freedom F equal to 6, Cv equal to 6 by 2r equal to 3r, Cp equal to Cv plus r, that is 3r plus r equal to 4r. Whereas gamma equal to ratio of specific molar heat capacity at constant pressure to the molar heat capacity at constant volume, that is nothing but 4r by 3r is equal to 1.33. The gas occupies 5.6 decimeter cube of volume at STP. So, volume of gas at STP equal to 5.6 decimeter cube. What is molar mass? So, molar mass of gas at STP 22.4 liters or 22.7 decimeter cube. Now, whatever the volume given, let us find out in terms of moles. So, number of moles equal to given volume by molar volume. Given volume by molar volume. What is given volume? Given volume is 5.6 decimeter cube by 22.7 decimeter cube. This is nothing but 1 by 4 equal to 0.25 mole. This is a 0.25 mole. In the problem it is given that amount of heat required to raise the temperature by 10 degrees centigrade at a constant volume is 52.25 joule. Rise in temperature at constant volume, that is delta U. Therefore, delta U equal to, it is nothing but QV equal to molar heat capacity at constant volume Cv into delta T. So, molar heat capacity Cv is equal to Q by number of moles into delta T is equal to amount of heat absorbed is 52.25 joule by number of moles, how much? 0.25 into rise in temperature 10 is equal to, this is 20.9 joule mole minus 1 K minus 1. So what is this Cv? But what is Cp? Cp equal to Cv plus R. So this is nothing but 20.9 plus 8.314. This is nothing but 29.214 joule. Right. Now, how do we find the atomicity? To find the atomicity, we must know about gamma value. So what is gamma value? Gamma equal to Cp by Cv. What is Cp? 29.214 by 20.9. This is nothing but 1.397. 1.397 is approximated to 1.4. If the gamma value is 1.4, the gas is a diatomic gas. The gas is diatomic gas. A piece of metal weighing 1 gram requires 6.80 joule of heat to raise the temperature by 1 degree centigrade at constant volume. Calculate the energy needed to raise the temperature of the same metal object weighing 200 gram from 20 degrees centigrade to 30 degrees centigrade. Here, the amount of heat required to raise the temperature of 1 gram of substance through 1 degree centigrade, it is nothing but a molar specific heat capacity. Therefore, amount of heat required to raise the temperature of 1 gram of the substance 1 gram of the substance by 1 degree centigrade is specific heat capacity. Specific heat capacity denoted by small m. Now here we have to find the amount of heat required to raise the temperature of 200 gram of the same substance from 20 degrees centigrade to 30 degrees centigrade. In problems, if the same metal object, even if it is not given, it is understood that we have to take the same metal object. So specific heat capacity C equal to Q, because here this amount of heat is required by 1 gram of substance through 1 degree centigrade. This is nothing but 6.8 joule per gram minus 1 degree centigrade minus 1. Therefore, now we have to find the amount of heat required to raise the temperature of 200 gram from 20 degrees to 30 degrees centigrade. So here delta T equal to change in temperature 30 degrees centigrade minus 20 degrees centigrade equal to 10 degrees centigrade. Now amount of heat required Q equal to C into M into delta T. See how much? 6.8 joule gram minus 1 degree centigrade minus 1 into mass of the substance 200 grams into rise in temperature 10 degrees centigrade. So here centigrade minus 1 cancelled, 2 and G minus 1 cancelled. Therefore equal to, if you multiply this 2 into 6.8, 16, this is 14, and of course 3 zeros here. So this is 14,600. This is 13,600 joules equal to 13.6 kilojoule. Let us do another problem. What is the value of Cp minus Cv for helium gas? So helium is monoatomic gas. Monoatomic gas and its molar mass is equal to 4. What is the relation between Cp and Cv? Cp minus Cv equal to R. Molar specific heat is equal to molar mass into Cp and molar mass into Cv. Therefore, M into Cp minus M into Cv is equal to R. What is the molar mass of helium? This is 4. Therefore, 4 into Cp minus Cv is equal to R. Implies Cp minus Cv is equal to R by 4. So this is the answer. So here for any gas, Cp minus Cv is equal to R by molar mass. For example, for oxygen, what is the molar mass of oxygen? 32. Therefore, Cp minus Cv for oxygen equal to R by 32. For nitrogen, it is 28. Therefore, the value of Cp minus Cv for nitrogen gas, N2 gas equal to R by 32. Let us do another problem. Calculate the number of kilojoules of heat necessary to raise the temperature of 60 gram of aluminum from 35 degrees centigrade to 55 degrees centigrade. Molar heat capacity of aluminum is 24 joule mole minus 1 K minus 1. Here, molar heat capacity means amount of heat required to raise the temperature of 1 mole of the substance. Here, the mass of the substance is given in grams, whereas molar heat capacity information is given. Therefore, we have to convert this mass in terms of moles. So, molar mass of aluminum, how much? 27 gram mole. Therefore, number of moles equal to given mass by W by M. This is 20. The given mass is 60. 60 by 27 is equal to 320 times 3 9 times. So this is number of moles. Now quantity of heat required to rise equal to C, that is molar heat capacity into number of moles into rise in temperature. What is C? C is molar heat capacity into number of moles into rise in temperature. Therefore equal to molar heat capacity 24 joule mole minus 1 K minus 1 into number of moles 20 by 9 mole into rise in temperature. How much? 55 minus 35, it is 20 degrees centigrade. 20 degrees centigrade, because it is rise in temperature, already we found the difference, therefore we can take K. So here K and K minus 1 get cancelled, mole minus 1 get cancelled. So therefore this equal to 3 here, 3 times 3, 8 times. Therefore 8 into 2 into 2, this is 8 times. How much this is? This is 8 into 20 into 20 by 3. So this is equal to 1066.66 joule. Therefore final answer is 1.066 kilojoule. So this is the answer. Please subscribe my channel, like, share and comment my videos. Thank you.